Hello. So we are going to solve Leetcode weekly contest 118 problem. So the first problem was very easy. It was brute force. So we are not going to solve that one. We are starting with the second problem. The problem is statement is maximize area of square hole in the grid. So there is a grid with n plus 2 horizontal bars and m plus 2 vertical bars and initially contain 1 cross 1 initially cell. The bar are 1 indexed. You are going to you are given two integer n and m. So uh, you will not get anything by reading that one. So let's understand the question by one example. So in the question they will give you two numbers n, two number n and m. So question is like that. They will give you n numbers of vertical lines, n plus 2 number of vertical lines and m plus 2 number of horizontal line, and all lines are one indexed. So the number givens are suppose 1, 2, 3, 4, 5 and 6, and same on the verticals. Horizontal lines are 1, 2, 3, 4, 5. Along with that they will give you two array. One array will contain some list of numbers and second array will also contain some list of numbers. So first array call horizontal one and second will call vertical one. So suppose here they will put 2 and 3, and again here they have putted 2 and 5. So these element that putted in horizontal one, that that array you can remove from the rectangles. This rectangle, suppose here put it 2 and 3, so you can remove this this horizontal line, two horizontal line and third horizontal line. On same way here, if in vertical index they have put it 2 and 5, so you can remove that second vertical lines and fifth vertical lines. So on, they will give you two array, and first array will represent how many vertical lines you can remove, a second array represent which vertical lines you can remove. So on, they will give you option to remove some lines, and after removing those lines you have to find out what is the maximum length of, what is the maximum area of a rectangle square that you can create by removing these lines. Suppose you are having 0 1 1 2 3 and 4, and here you are having 1 1 2 3 and 4, and in vertical one you can remove, 2 and 2, remove only 2, and in horizontal one you can remove 2 and 3. So by removing this and this, by removing this one this, you will not have any horizontal line, and by removing this you are not having this line. So let's erase this one. So by after removing all the horizontal lines, you will have this much horizontal area, and you have removed third and fourth vertical second vertical lines only, so you are having this area. So the maximum horizontal length is 2, and maximum horizontal length is this much, and maximum vertical length is this much. So the rectangle area is minimum of both. So suppose maximum vertical length is x, and maximum horizontal length is x, and maximum vertical length is y. So the maximum rectangle area will be minimum of x comma y to the power 2. This will give you the area of maximum rectangle that you get by removing this one. So the thing is you have to find what is the maximum horizontal length you are getting by removing these lines, by removing these points, and what is the maximum vertical length that you will getting by removing these vertical lines. So let's go on the question once. So in this example you are having 1 2 3 three vertical lines. In three vertical lines you can remove second one. So by removing second one, you will get this much horizontal length, and you can remove second and third vertical length. So second is this and third is this, so you are having this much vertical lines. So you can create this much rectangle area. So the main task is, suppose we are having this line and this line, in which you can remove this one and this one. So if you remove this one, you will get this area plus this area, and if you remove this one, so you will get this area, so this area. So by removing each line you are creating one extra horizontal space, but in between you are having array one line that you can't remove. So the maximum area is how many consecutive horizontal lines. So the maximum horizontal area that you can create without any line will be equal to how many consecutive horizontal line you can remove. Suppose if you have two option, remove this one, not you can't remove this one and this one. So the rectangle, your maximum horizontal line will be how many consecutive lines you can remove, a plus one. So if you can remove two consecutive lines, so the max. So suppose you can remove this horizontal line and this horizontal line and this horizontal line. So the maximum horizontal area that you can create is equal to how many consecutive horizontal line you can remove, a plus one. So here if you have removed this one, the two consecutive lines you can remove, a plus one is equal to three horizontal area you can create. Three length horizontal area you can create. So on here you can create two length horizontal area. So the how much so horizontal area that you can create, it depends to how many consecutive lines you can remove. So you have to count you. So once you can calculate what is the maximum length of horizontal lines that you can consecutive horizontal line that you can remove, that will the maximum horizontal area that you can create. On the same way, how many consecutive vertical line you can remove, if you remove two consecutive vertical lines, so the maximum vertical area you can create is 2 plus 1. So this much horizontal area you can create. So once you will be able to calculate maximum horizontal area and minimum horizontal maximum area and horizontal vertical area, then you can calculate what is the maximum area that you can calculate by removing these lines and making a square. So suppose if horizontal area you can calculate is 3 and vertical area that you can create is 2, the maximum square you can make is minimum of horizontal 1, minimum of horizontal and vertical to the power 2, because the rectangle the square length will be the minimum of horizontal and vertical area that you can create. Suppose if horizontal area is this much, so suppose this much is 3 length and this much is suppose 5 length. So the square that you can create in between, it will be the 3 length only, because 5 length of square you can't create. So the area will be minimum of both, and 3 into 3 is equal to 9. So ninth length area you can calculate. So the thing is, now the next problem is how we can calculate how much vertical area and how much horizontal area you can create. So the thing is very simple. They will give you index of lines. Just sort the index and count what is the maximum consecutive line, what is the maximum consecutive line. So for that, just compare if ith element vi is equal to 1 plus vi minus 1, then mean it is consecutive line. So our task will be, what is the maximum length of consecutive subarray in sorted way. So for that, first we will sort the horizontal indexes that you can remove and vertical indexes that you can remove, and maximum this is maximum variable that will keep track of what is the maximum length, what is the maximum consecutive lines. So here we are comparing, if that index value is 1 plus previous index value, that means that is consecutive indexes. So we if not is equal to that one, that means it's not consecutive. So we are starting with 2, assigning count is equal to 2, but if this condition is not hold, that means that is consecutive lines. So we are incrementing the count. Whenever count variable is greater than the maximum count, we'll update the maximum count. On the same way, we'll find out the what is the maximum consecutive indexes that you can remove in vertical lines, and we'll find out the minimum of both vertical space and horizontal space, and we'll make power up to that will give the area of area of the square that you can generate by removing these horizontal lines and these horizontal lines and these vertical lines. The time complexity of this approach will be, here we are sorting, so here we are sorting, so it will take n log n. Here we are sorting again, so it will take l log n. So time complexity will be approximately n log n, where n is maximum length of h vector or r vector that we are removing. Thank you.